Hi guys, it's Kristine and Mendoza here. Welcome back to another episode of MadSci. In today's episode, we are going to discuss about passivity. In today's objective is to understand what is passivity and what are the three types of passivity. Generally, metals react with concentration of acids and bases. But in group 8 metals and some other transition metals react with concentration of acids, but after some time they stop reacting. Well, what is this state of non-reactivity called? Well, the state of non-reactivity is called passivity. So we can define passivity as the state of non-reactivity after an initial reaction. So let's find out more about passivity. Passivity is when an active metal, under certain environments, become passive. This is because of the formation of thin adhesive oxide film in the surface of a metal, which acts as a protective barrier to corrosion. Well, an example of this is aluminum, because aluminum is a corrosive resistant that has a precipitating layer of Al2O3, or also known as aluminum oxide. Let's now define what is passivation. Passivation is the change from an active state to a much less active state. While in an active state, this is where corrosion occurs. And in the much less active state is where the corrosion is nearly eliminated. Now, let's move on to the three types of passivity. The three types of passivity is the chemical passivity, the mechanical passivity, and lastly, the electrochemical passivity. The first one is the chemical passivity. This is the passivity which is obtained due to the action of a chemical like HNO3 or nitric acid on a metal surface. An example of this is when an iron rod is dipped in concentration HNO3 or nitric acid. If slowly dissolves initially, but after some times, the metals stop reacting with HNO3. After this stage, iron rod does not dissolve even in diluted HNO3 or nitric acid. The second one is the mechanical passivity. It is the insolubility of the metal due to the formation of an invisible film of metal oxide. An example of this is the formation of thin layer of PbO2 or lead dioxide on lead prevents the dissolution of lead. It is also shown by copper, nickel, and etc. Lastly is the electrochemical passivity. During electrolysis, the electrodes sometimes dissolve in the electrolytic solution and produces ions. But after some time, dissolution stops due to the formation of a thin invisible metal oxidic layer on the surface, which is responsible for electrochemical passivity. That's it for today's episode of MadSci. Hope you guys enjoyed it. Don't forget to click the subscribe button below. See you guys next time. Bye!